You all know the saying, right? I want a conference that starts with an evacuation and then slowly works up to a climax. I really hope this is the climax you have been promised. My name is Lars. This is Dragos, and we are with Adobe. Well, not that part of Adobe. What a lot of people don't know, Adobe is a really, really big company, right? We have 3 major businesses, also known as Marketing Cloud, Creative Cloud, and Document Cloud. And what you just saw, that's essentially Document Cloud. Creative Cloud is what everyone knows as Photoshopping. And Marketing Cloud is what nobody knows, but what you're using every single day, because we are behind some of the biggest brands in the world. There are more than 100 products that Adobe is offering. And you know you have a company with a lot of products when there's a Wikipedia page for the products, and it actually needs expansion. And a lot of these, speaking of Wikipedia and speaking of lists, a lot of these companies came to us through acquisitions. And this means that we are dealing with a very, 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 very diverse technology stack, right? You can imagine we have Adobe and you just pile stuff on top of it. And at the same time, we are big users of the cloud. We are using Amazon Web Services heavily, and we are investing heavily in using Microsoft Azure. So this is already a big part of our business, and reflected in the fact that we call this Document Cloud, Creative Cloud, and Marketing Cloud. So some of the biggest brands in the world are running their digital experiences on Adobe, and they are asking the same questions that we're asking. How do we bring all of these products together, right? How do we make our own products play together, and how do we make it play together with the rest of the world, right? Because we're not living in a world of monocultures anymore, unless you talk about chat programs that we're using in the workplace. And we've been asking the question, okay, how can we make it work better? And our answer is, let's build a cool website, right? Let's build Adobe I/O as a website for developers and talk about how great everything is, and that's it. Okay, I'm just kidding. Building the website and talking about how great everything is, that's my part of the job. Dragos' job is to actually make it work. And in order to actually make it work, we've been asking ourselves, okay, who is actually building these integrations, right? Who is building apps using our APIs, and who is building experiences using Adobe products? And there's a wise man who gave us that answer. And the answer is developers. So the next question then is, being in this very inquisitive mode, you see, I'm asking questions more than giving answers. What do developers want, right? What is it? What is it that developers want? And I'm a marketer, so I said, okay, let's do some market research. Let's build a list. And I found out, well, what developers want is they want to write code, they want to deploy code, and they want to manage servers. And then I talked to actual developers, and Michael, for instance. Michael, please say hi. He told me that list is wrong. That's the correct list. So strike manage servers and add drink beer. Okay. We can do this, but how do we get there, right? And well, you at a serverless conference, so I know what you are all here for. You're all here for the beer. So the problem with servers is you can't live with them, right? They're annoying, but you can't really live without them. And at least at the first serverless conference, we had a flood of people on Twitter telling us, "You are all stupid. You're all insane. What you call serverless, they are servers. They are servers. You just can't see them, right?" And that's exactly the point. We don't want to see them. So here is our 4-step program for becoming serverless. And just because I really like the word serverlessness, this is our 4-step plan to serverlessness. Step number 1, servers are dangerous, right? So what do we do with servers? We put them behind glass. And the best picture I found for putting something that is useful and important but dangerous behind glass is this, right? So we are putting servers behind glass, and what everyone would call glass is what we call APIs, right? And APIs, putting everything that we have behind APIs, this is implemented through our API gateway, which coincidentally can be accessed on adobe.io, and adobe.io is also the endpoint for all of our APIs. There's another advantage of putting everything behind glass is you have a central point for throttling, for caching, for authentication, for logging, right? So all of these things that individual developers like to forget because these are the boring non-functional requirements, we can handle them in a central place and just pile them on Dragos so that he can take care of it. And it allows us to go from a dumb proxy to becoming a real smart gateway for services. And this can also help us to hide the monolithic architectures that we have in a lot of places, right? It helps us to establish best practices for APIs. If I would tell you that we have APIs that are doing modifications on GET requests, you would probably believe me. So, and additionally, it provides easy way to access all of these APIs. And all of this technologically, all of this is based on Nginx, OpenResty, and Lua. And if you really like it, you can check it out on GitHub because all of this is open source. And I talked about establishing API best practices, and this is something that is really, really near and dear to our heart. And the reason for this is something that our HR calls employee number 9941, and that other people call the REST father. I just call him Roy. But basically, if you mess up your REST API and you manage to talk about this on a mailing list within Adobe, Roy will reply to you. And I think, Dragos, you've been on the receiving end of these emails, and it's a good thing, right? It's a good thing to establish best practices and to make APIs accessible. But enough about APIs. The next thing that you need to do is you need to contain your applications. Why is containment important? The biggest reason is containment makes it easy to transport your applications and to move them around, right? So you can strap them on a container and then you ship them from one location to another, from one cloud to another. And this is something where we have a project called Ethos. And Ethos is essentially 3 things. It's a standardized container operating system and container management system. It is a standardized continuous integration and continuous deployment pipeline, because again, if I would tell you that some of our products have manual deployment processes, you would probably believe me. And finally, we have a centralized way of handling feature flags, right? So that we can route a certain number of requests to a new version and see how customers like it and if it actually can be integrated. So the next step to becoming truly serverless is to put code on the short leash. The problem with code is it's incredibly useful, but it can bite you. So let's put it on the short leash so that it can't bite you. And this is exactly the serverless runtime that is at the core of our platform. And a wise man said, never trust a computer that you can't throw out of a window. And an even wiser man said, never trust code that you can't terminate after 1 second. Right? And the 1 second termination time, and a lot of you would say, 1 second, well, that's 1,000 milliseconds, that's a long time. But really, this is a change in mindset, right? It means if your code can only live 1,000 milliseconds, there's only so much it can do. But the biggest thing that it can do is it can call other code, right? So you can easily modularize your code and can manage it and can turn a big beastie monolith into a lot of manageable services. So using serverless patterns for integrations, this gives you a number of things. It gives you, on the one hand, something that I would call webhooks plus, right? And Tomasz has been talking about this in the previous presentation, how serverlessness is really a continuation of webhooks with other, and I would actually argue with improved means. Two of the biggest advantages that we get here is, number one, low latency, right? For a typical webhook, you would have to make a call outside of your data center, outside of your cloud, into somebody else's cloud and data center, and then get the response back. And this is fine for things where we are used to waiting, right? This is fine for the Slack command where we say, oh yeah, it's fine. It's going to take a second or two. This is not fine for anything that is critical to experiences, right? So whenever we have a service that is, in the end, being rendered as part of a website, as part of a mobile application, we want to reduce latency as much as possible. And we can do this by having the runtime really, really close to the event-generating source, which is probably also one of the reasons why you would rather use AWS Lambda together with S3 than you would use Google Cloud Functions or Azure Functions. The other big thing about this is it reduces maintenance, right? And again, we all love having servers. We don't like caring for servers. So this is great that it takes this away from us. And our needs for a serverless runtime were actually pretty simple. We want to have the ability to run code from people that we don't trust. And people that we don't trust, that includes, on the one hand, our customers. This includes our partners. But most of all, this includes our colleagues, right? So we want to run that code without running at risk of them breaking our code. Number two, we want to have extensibility, right? So we want to be able to inject the right kind of context, the right information. Who is the logged in Adobe user? What is the Adobe ID? Is this a visitor that is coming to the site for a repeated time? We want to be able to inject that and to inject that with very, very low latency. And finally, as much as we love Microsoft and as much as we love Amazon, we really would like to keep dating them casually rather than marrying them for life, right? So having a certain degree of cloud provider. Okay, I think that is so. So rather than committing on one single cloud provider forever, we want to have independence and we want to have the ability to move around. So what we did was we started a project internally with and we came up with the coolest code name ever, codename Blade Runner. And we even found a movie poster, Blade Runner 2049. So that's essentially Blade Runner 2. I'm really excited to seeing Harrison Ford again. But our director of engineering, he said, "Hey, are you guys serious about the delivery date? 2049? That might be a bit late." And okay, so what we did then is we said, okay, maybe there is something that we can use already, something that is useful and that is powerful. And there's a website famous for cats and octopuses that we went to, and we found OpenWhisk. And you heard a lot about OpenWhisk. But the interesting thing is that OpenWhisk provides us with an extensible, cloud provider independent, and open source runtime that we can use in our platform, and that is great. Right? The thing that is not so great is that it's entirely owned by another company, that they completely control the IP, and that we said, okay, we would like to work with you, we would like to contribute, but is there a way how we can do this with open governance, right? Is there a way where we can all pitch up our TPs and live together? And it turns out there is such a place, which is the Apache Software Foundation, and this is why we've been working with IBM, or IBM has been working with us to bring OpenWhisk to the Apache Software Foundation. And if you would like to know how the Apache Software Foundation is working, just visit that URL and you will see the mail thread that has been following the incubation proposal, right? So all of this is still under discussion, but we are very excited about this because it is not just taking a great piece of technology, but it's combining a great piece of technology with a great and open community. So the fourth step of our four-step program to serverlessness is waiting for the call. And waiting for the call means that instead of our servers having to make all calls and instead of having systems that are polling each other constantly, we turn the model around and turn to an event-based integration, which means if something happens, the service where something happened will call everyone else. And instead of calling everyone else literally, we actually handle that in a centralized way through an event gateway. The idea of the event gateway is one service produces events, other services can subscribe to these events, and events can then create callbacks for asynchronous processing to orchestrate functions. So for instance, you can have a small function that is doing something. Once it's completed, it's simply saying, I'm not going to call the other function directly, I'm just going to call an event, and the other function will then be called by the event bus. And it will give us reliability and scalability because the event bus can handle things like distributing events. It can handle things like retrying if a service doesn't answer. So before I continue to bore you with additional slides, I would like to hand over to Dragos, who is going to give you a demo. And as everyone loves bots, this demo is going to involve bots.
Thank you, Lars. So a nice thing about serverless is not just the optimizations or the cost savings that it gives us, but also the way that it may impact our lives. So one might not know how to program a backend, but let's say a fifth grader could know how to write a JavaScript function, actually influence maybe our lives. Maybe one day we'll even see a demo where I would love to run that demo where I could use my voice, call a drone from 10 miles away, see the drone coming into this room and bring something to me or something like that. But if you think of like what this impact may be for a person that has some health issues, you know. So for the demo today, I wanted to use my voice and send a command into the cloud and run that command into OpenWhisk and get something back from an Adobe product. For instance, I want to find out how many page views I had this month, you know, just like driving or just because I'm curious. So the setup is that I'm going to use Alexa, which is on my phone, and I'll connect this with a cable. I'm going to run a quick demo. So when I say I will really mean you in the next sentence. Okay. I wanted to train Alexa to say you, but I can't. So let's make a quick test if I can get sound here. So let's say, Alexa, am I smart? Thinking.
Of course you are. You're a human, one of the smartest beings in the known universe.
Yay, we got it. So we got connection. So I'm going to connect Alexa through the gateway to OpenWhisk. As Lars was saying, you know, being an IBM company also looked and wanted to make this test that it actually can integrate with other things as well, right? So it turned out that it works pretty good. So for those of you who are not familiar with Alexa, there's on developer.amazon.com. It's a very simple, quick start. You can go there and you create a skill to Alexa. And you can also create something that is called like the invocation name, which in this case is going to be Adobe Analytics. Next, think you have to train Alexa to understand your intent. For instance, if I want to say I want to see the page views, then I need to tell Alexa that I will be using some phrases for that, like how many page views this month, or page views, or as the more phrases you give, the better Alexa can learn you. And Alexa also has this concept of slots, like if I want to see not just the page views, but like visitors, unique visitors, and so forth, I can use some variables. The code is just here for the demo. I created a simple gist. If you're interested to see the JavaScript code behind the scenes, you're going to find it there. Provided that an OpenWhisk environment is up and running, which I'm not going through in this demo, there is a very nice CLI to add a function to an action. So I'm here creating an action called Alexa, and I'm adding the Alexa demo JavaScript code, which is in the gist. The last thing you have to do in Amazon is go into a page like this. It's not quite visible, but in that text box below, you pretty much give the HTTPS URL to where the function runs. All right, then before the demo, before this works end-to-end, we were trying to run this without the gateway, right? But it turned out that you actually can't because there's different systems and systems. For instance, in this case, Alexa may send you a different authorization mechanism, and OpenWhisk wants a different header. So in kind of this demo, we have the gateway pretty much validate the Amazon signature and then transform a little bit the code in order to call the function. All right, without further ado, let's run the demo. Okay, Alexa is working. So, Alexa, use Adobe Analytics. I was thinking it's my 3G.
Welcome to Adobe Analytics. Which report suite would you like to use? Adobe I/O Portal, Partner Day website.
Partner Day website.
Okay, using the Partner Day report suite. How can I help you?
How many page views this month?
The total number of page views this month is 3,871.
Okay, how many visitors this month?
The total number of visitors this month is 1,231.
Thank you.
Serverless is cool, isn't it? Goodbye.
I trained Alexa a little bit. That was my demo. Just to give you a thank you. This is just to give a very short glimpse of what you can do with serverless if you just know a little bit of JavaScript code and how this can or may impact our lives. So Lars, I'll hand it over to you from here.
Well, there's not much to say than thank you, and don't forget to check out Adobe I/O. And we're very happy to answer your questions. That means Dragos is.